Now let's come back to the priority system. We have allocated every work order a lead time, and this lead time has got enough cushion, and this is what we call as time buffer. This time buffer is nothing but a time which, when subtracted from the due date, is the release time for the material to start production on. So this whole time buffer for a particular work order is divided into three parts. The first part, where the chances of it getting out of the system in the first part is high, and that means if it is in that first part or first 1/3, we know that everything is okay. But if it falls into the second 1/3, we know that there is a small deviation from normal or from expected, and more than deviation beyond 2/3, that means there is a cause to worry. Corrective actions need to be taken. Now this priority system needs some calculation, and this is much simpler. Due date minus the time buffer is the release date. After the release date, the time is passing. So if for one particular order it is just 2 days past, it is in the green band. Don't worry, you don't have to bother about items in the first 1/3 part. But if for all the work orders more than 1/3 time has passed, all those work orders come into the middle band. You need to monitor them and find out where they are. Don't do any action, because still our probability says the chances are that they will be out of the system on time. But if 2/3 of time has passed and the order is still not out of the system, that means if it is not set for shipment or lying in the shipment yard, corrective action needs to be taken. You need to chase it. Now once you chase it, you are setting a priority to the order. This is going to reshuffle a lot of other work orders. But you don't worry about it, because it is not that all of them require chasing. And if you systematically analyze, that means the ones which are consuming more than 2/3 are actually telling you where the disruption to flow is. So this is also telling you or giving you a focusing mechanism. A time-based solution also then meets all the requirements of the concepts of flow. We are trying to increase flow, reduce lead time, and in trying to reduce the lead time, the mechanism is to avoid overproduction. The second concept. To avoid overproduction, we are only allowing certain number of items to be on the shop floor, or we are making sure that we do not release too much and much ahead of time. Much ahead of time is overproduction. So you produce an item when you want it to be produced. So we are limiting production by releasing the material at a requisite time, and this time is good enough for the material to be out on due date. Now comes the fourth concept. The fourth concept of flow is there should be a practical mechanism to allow you to focus on balancing flow. So we have just learned that if we have a priority system inbuilt in this material release system, time-based material release system, which tells me that how many of these items land up being in the uncomfortable zone of consuming too much of my throughput time. And if a systematic analysis is done and we find out that most of the items which are in the risky zone happen to be stuck at a particular machine or a resource, it is quite likely that you should focus on that resource and try and improve the flow through it. The rate of production needs to go up. Some priorities need to change on that machine or the work center so that most of the items flow out of the system at the right speed and at right time. We just seen that if we replace inventory or space as the base for controlling overproduction by time, we still get a robust system, but this robust system can now have much wider application than the Kanban system as it applies to Toyota, or the assembly line system that applies to the Ford method of production. We are now very clear that Toyota required a very stable environment for the Kanban system to work. Many industries like electronics, machine tools, garments don't have the privilege of enjoying a stable environment. Moving the base to time makes the flow concept much more applicable to a wider range of industries than the traditional ones which use this flow concept. The time-based approach to controlling overproduction made it more robust and applicable in uncertain or unstable environments. The application developed to implement this concept led to the creation of drum buffer rope. When Dr. Goldratt used time as the base to limit overproduction and subsequent control mechanisms and priority systems, the system which resulted was called drum buffer rope. We shall discuss drum buffer rope and how exactly it works in subsequent sections. But here it is just sufficient for me to mention that this system, which tracks all the work orders on a shop floor based on how much of throughput time has already been consumed and what is the status of the work order. If 1/3 of the throughput time has been consumed and the work order is already on the shipment deck, don't worry about it. And if 2/3 of the throughput time have been consumed and the work order is still not at the shipping deck, don't take any action, but locate it and take a good guess whether will it be out on time or not. And if more than 2/3 of the time have been used and this work order is still nowhere near finishing, it's a worry. And if by taking all those orders which fell in the worrying zone, one starts analyzing the cause, this would lead to the place where the flow is getting disrupted. This place technically would be a capacity constrained place, or somewhere where there is some policy in place which is forcing the resource to take more time than it should, and hence the delay in processing. It's a beautiful mechanism of control, a beautiful mechanism of making sure that the flow keeps increasing or balancing the flow. It tells you where to go, it tells you what to do. But this is just the overview. There are certain tools required, there are certain procedures to be done to actually process the data and bring out the information which can actually tell us how to go about doing this. Now, let's take a situation where the majority of the orders are now in the red zone. That means there is a slowness in the process. They have still not breached the throughput time, but majority of the orders are coming into the red zone. My assumption was that the buffer time, the time buffer that I'm using to translate the dispatch date into the release date was constant. Now, if I don't look at how much of items or how much of material is present in the pipeline, I will again violate the first principle of limiting excess material on the shop floor by releasing blindly material on the shop floor. So in this mechanism, if the amount of red goes up, and this red is because there is a resource which is now very close to its full capacity, the release gets tweaked. We immediately add more time buffer and we increase the time buffer. But if by analysis we find that all the orders are finishing off before even 2/3 of the time buffer gets consumed, we slash the time. And the more time buffer we slash, the quicker the flow, and that is the aim. So as we keep reducing the time buffer, we keep exposing constraints or obstructions to flow, and these get highlighted by the priority system. The application which so explains and interconnects all these various parts is called drum buffer rope. Drum is a schedule through which we release the material on the shop floor. Rope is nothing but a feedback mechanism which tells you whether to increase or decrease the flow of this material. Buffer is the time, the throughput time, the time buffer that we have assumed that an order will take for going through the system, or the manufacturing lead time. These three elements put together make the application called drum buffer rope. By moving the base to time, Dr. Goldratt produced drum buffer rope, an application which is now more versatile and applicable to majority of manufacturing environment. However, we have also learned that every application is a concept with certain assumptions. Drum buffer rope also has an assumption. Drum buffer rope will yield the desired results only if its fundamental assumption that the touch time in the whole throughput time is less than 10%. Secondly, it is not very easy to calculate the touch time and extra, etc. in a project environment. So drum buffer rope is not applicable as it is to the project environment. However, it does have a great degree of applicability in majority of the manufacturing environment.